If you are following these videos in order, this is where we left off. The speed of the boat was given by this 11.2 kilometers per hour, and the position of the boat at 12 noon, 1 p.m., 2 p.m., and 3 p.m. are right here. Now what we're going to do in this next section is we're going to try to locate our boat at any given time from me. Now, the first problem we have in trying to do this is this. If I do it graphically, it's easy to see where the boat was an hour later. If I spotted the boat here, in 1 hour, the boat was here, and that's very simple to look at. It is negative 15 along the x, and it is 10 along the y. But say I wanted to find where the boat was an hour and 10 minutes ago. An hour and 10 minutes from my initial location. So an hour and 10 minutes, it will travel 1 hour plus an extra 10 minutes. Now the first problem I have is minutes. I know 30 minutes is halfway between that. This is 1 hour, here's 30 minutes. 15 minutes is right here. 10 minutes, somewhere over there. So it sort of looks like negative 12, 9. Not exactly sure, but that's what I'm guessing. So what I want to do is I want to find exactly where this boat is. What is the boat's position if I am watching it? Now, if I am watching it, then that means there is a vector I am following. If I start at the lighthouse and I first spot the boat, I could actually compute the vector from me to the boat. In 1 hour, I need to compute the vector from me to the boat an hour from now. In 2 hours, I will need to compute the vector from me to the boat's new location in 2 hours. In 3 hours, I need to compute the vector from me to the boat. And if you notice, the vector just keeps on changing, and this purple vector right here is following the path of the boat. So that's what I have to come up with, a general location that will track the boat anywhere, even when it goes off my grid. So I do that by the following section: vectors and parametric form of a line in 2 dimensions. I'm kind of running these out of order just so that the information fits in nicely. But before we do that, I'm going to look at our first picture, and we're going to go over adding vectors for a while. So let's start off pictorially. Pictorially, if I want to add vectors, there exists some vector which I need to compute, but we're not going to worry about it. I'm just going to draw it right now because we're doing this pictorially, from me to the boat. And I already have the vector from the vector the boat is traveling. Remember, we call that the velocity vector. If I call the location vector, vector A, and the velocity vector, vector B, and I want to add vector A plus vector B, do you remember that? What I first do is I go from start to end, start to end. And I draw the vector right here. This green line represents vector A plus vector B. Now, if I want to say find vector A plus 2B, so the first thing I have to do is I need 2 vector B's. So here is vector A, the blue line, and vector B, this becomes vector 2B. And if I draw the vector from me to the new location, this becomes vector A plus 2B. Say I wanted to add vector A plus 3B. Moving along, that would mean that I would need 1 to all three of these guys. So here I have vector B and vector B. So if I draw the vector from B to the new position, this becomes vector A plus 3B. Now I'm just going to move the green line and hopefully you could follow along. Now if I wanted vector A plus half B, wouldn't that be right here? And vector A plus 1.5 B would be, say, about right there. And vector A plus 2 1/3 B, so here's 1, there's 2, 1/3 would be about right there. Notice that this green vector is tracking the position of the boat. Here it is in 1 hour, say 1 hour and 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes, also known as 2 hours, 2 hours and 10 minutes, 20, 30 minutes, 40 minutes, 50 minutes, 60 minutes. And if I continue with this and put another vector right here, I can now track it for, say, 3 hours and 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes. And I can continue that on. So what I need to do is, I need to create some equation that will let me do this and just use math. Let me see the time on the clock. Well, I seem to cut it short. I only have 3 minutes to go. Please watch the next video.